Good morning. In the context of the 9th Conference, International Interdisciplinary Congress on Renewable Energies, Industrial Maintenance, Mechatronics, and Informatics, CIERMMI 2024. We are pleased to present the conference, Teoría Electromagnética, Pulso Electromagnético, and el Laboratorio. That is to say, electromagnetic theory, electromagnetic pulse in the laboratory. This work was developed by GUZMÁN-TINAJERO, Pedro, HERNÁNDEZ-GÓMEZ, Víctor Hugo, and CASTRO-FUENTES, Aide. They are faculty members of the Facultad de Estudios Superiores Cuautitlán at the Universidad Nacional Autónoma de México. Welcome, everyone. This presentation will cover the following points: Introduction, Methodology, Results, Conclusions, Acknowledgements. Let's start with a brief introduction. The Facultad de Estudios Superiores Cuautitlán, FESC, part of the Universidad Nacional Autónoma de México, UNAM, is an important academic center located in the municipality of Cuautitlán Izcalli, State of Mexico. It was inaugurated on April 22, 1974, and has been in existence for more than 50 years. It now has 17 degree programs and has approximately 18,000 students enrolled. In the curriculum of the Telecommunications Systems and Electronics Engineer, ITSA, taught at the FESC of the UNAM, is the subject of electromagnetic theory, located in the 5th semester of the career and marked as a theoretical and practical subject, therefore includes a laboratory, has 10 mandatory credits, so it is of great importance in the training of future engineers. For the scope of this article, we will focus on electromagnetic pulses generated in the laboratory through voltage variations, such as those produced by the Van de Graaff generator. The problem we wanted to attack was the general ignorance of our students about the EMP phenomenon and the importance that it has in the proper functioning of electronic devices today. The contribution of this experiment is the realization of a controlled EMP, as well as the design and measurement of the basic circuit to raise the voltage. All this is visually attractive to students and motivates them to deepen the subject. For all of the above, we developed a laboratory practice called Passive Circuits and Electromagnetic Pulse, which has already been included in the Manual of Laboratory Practices of the Physics Department of the FESC UNAM. Let's now discuss the methodology of this work. For the elaboration of this work, first, theoretical research was carried out that included basic elements of the electromagnetic theory subject, the programmatic contents approved by the H Technical Council of the faculty, and the quality guidelines according to the ISO 9001-2015 standard. We worked with several academics from the electromagnetic theory faculty to distribute the work equitably. Considering that Maxwell's equations pertain to the interaction between electric and magnetic fields, we decided to include an experiment with the necessary characteristics to make it engaging for students while simultaneously demonstrating the relationship between these fields. For this project, we used the Van de Graaff generator of the Physics Laboratory, FESC, which works with the friction of the band on a roller and the induction of charges to the generator shell, see Figure 1, to produce a controlled EMP that allowed the students enrolled in the electromagnetic theory course to observe the effect of the same on electronic devices. Compared to other techniques such as nuclear, the PEM generated by the Van de Graaff generator is of low power, which allows students to understand and measure it more safely. We also built a passive oscillator circuit with laboratory elements, capacitive inductive circuit, and accompanied it with a diode to produce the effect of voltage growth in the capacitor. See Figure 2. We consider it important to mention that, although we could have worked with a power transistor, to make the experiment more didactic, we used a basic button switch. By using the basic switch, we were able to allow the students to interact with the circuit and demonstrate the relevance of the operating frequency in a practical and didactic way. The laboratory of the physics department of the FESC is certified under the ISO 9001 2015 standard, which is why when introducing a new practice it was necessary to comply with certain organizational guidelines. According to Departamento de Física 2024, the structure of each of the practices of the manual for the electromagnetic theory laboratory consists of 8 main elements. See Table 1. The proposed practice complied with these guidelines, and additionally, being a product of a collegiate work, it could be integrated to a UNAM program called Program of Support to Projects for the Innovation and Improvement of Teaching, PAPIME for its acronym in Spanish, which indicated additional elements to be considered, which was fulfilled in the drafting determining the final structure of the document. For the electromagnetic pulse part, the Van de Graaff and a basic calculator were added. The students were asked to place a certain level of band velocity to generate sufficient charge, and then at different distances to measure the impact of the electric field on the electronic device, as can be seen in Figure 4. The final work consisted of 15 pages, including the cover page. Its name was Practice 3, Passive Circuits and Electromagnetic Pulse. It was presented to a pilot group of teachers for their observations, and later to a pilot group of students to evaluate its impact. Let's now talk about the results of this research. During the development of the study, a significant understanding on the part of the students concerning the concept of electromagnetic pulse was observed. This finding suggests a deep understanding on the part of the students about this phenomenon, which indicates remarkable progress in their learning. In addition, the teachers participating in the study were able to develop and strengthen their didactic skills by incorporating new tools and strategies to improve the teaching of the electromagnetic theory course. This pedagogical adaptation can be considered an important achievement for the teaching team, as it allows them to offer a more enriching and effective educational experience to their students. Regarding the students' understanding of the operation of a voltage booster circuit, the results showed a satisfactory level of comprehension. This ability acquired by the students suggests an improvement in their knowledge and skills in the field of electronics and telecommunications engineering. As conclusions to this research, let us consider the following. The results obtained in this study provide a clear view of the positive impact that the lab session had on students' learning and the professional development of teachers. From these findings, several important conclusions can be drawn. Effectiveness of the pedagogical approach. The lab session was effective in enhancing students' understanding of fundamental electromagnetics and electrical circuit concepts. The integration of theory with hands-on practice enabled a deeper and more meaningful comprehension of the studied phenomena. Teacher development. The results indicate that the participating teachers were able to strengthen their didactic skills and adapt their pedagogical approach to offer a more enriching learning experience. This aspect is crucial to improve the quality of teaching and learning in the classroom. Practical application of knowledge. Practice allowed students not only to understand theoretical concepts but also to apply them in practical situations. This is essential for developing practical skills and fostering critical and creative thinking in students. Fulfillment of objectives. It was confirmed that the objectives set for the practicum were satisfactorily achieved. Students were able to observe and apply electromagnetic phenomena, while teachers were able to strengthen their course with new tools and approaches. In summary, the results highlight the importance of educational practices based on experience and active interaction with content, both for students' learning and for teachers' professional development. These findings can serve as a basis for future research and the continuous improvement of academic programs and teaching in general. Finally, the authors of this work would like to first thank you for listening to us and then extend our thanks to the Universidad Nacional Autónoma de México, the Dirección General de Asuntos del Personal Académico de la UNAM, the Facultad de Estudios Superiores Cuautitlán, the Department of Physics of the FESC, and the Claustro de Teoría Electromagnética for the facilities for the development of this work. This work was carried out with the support of the UNAM DGAPA PAPIME PE 103424 program. Thank you very much, and see you soon.